Okay, we meet again today. I'm Nurul. I'm going to discuss about our topic for Intelligent System class for week 9. This is about the neural network and deep learning. So in part 1, I'm going to discuss about the introductions to neural network. So basically, neural network is inspired by our brain, which is when we compare our brain versus the machine, our brain can actually recognize pattern, can do associations, can do very big complexity task, and then they can also do noise tolerance. How about the machine? The machine can do calculations, and it's very precise and can solve the problem using logics. So when we combine the ability of the machine with the model of our brain, it can be something that is very good. That's what the neural network try to do. So the features of our brain is it contains 10 billion of neurons. On average, several thousand connections, hundreds of operations per second, and it die off frequently. It never get replaced. So when we get older, our brain start to degrade because we cannot get any replacement for the die cell. And then it compensates for problem by massive parallelism. So the way that our brain work is using parallelism. This is the structure of neurons in human brain. So the neuron has a cell body, this is cell body, a branching input structure, this is the input or dendrite, and output or axon, and axons connect to dendrite, to the other from the other neuron through synapses. Okay. What do the synapses do? It transmits electrochemical signal from the dendrite input through the body and then down to the axons, and then so it transmits to the other neurons. Okay, when does the neuron activated? It only activated when its input signal exceeds a certain amount or threshold in a short period. Synapses vary in strength. Good connections allowing a large signal and slight connection allowing only a weak signal. So if the signal is very weak, the neuron will not activate it. So this is like the analogy of when we want to classify between positive and negative class. So good connection mean positive class and weak connections mean negative class. So the neuron will not be activated. Okay, how about the learning? Learning in nature, in a biological system, means learning by adaptations. The young animal learns green fruits are sour, yellowish or reddish ones are sweet by adapting the fruit picking behavior. At the neural level, the learning happens by changing the synaptic strength, eliminating some synapses, and building the new one. How about learning as optimizations? The objective of adapting is to achieve a better state. For example, the animal likes to eat many energy-rich, juicy fruits that make its stomach full and make it feel happy. The objective of learning in biological organisms is to optimize the amount of available resources, happiness, or in general, to achieve a closer to optimal state. So, every animal needs to know what is the optimal states, and then learning means they want to optimize the effort to achieve a closer to the goal. Yeah, the goal is to optimal state. Okay, as The first artificial neurons was introduced by McCulloch and Pitts in 1943 in a paper with the title A Logical Calculus of the Ideas Immanent in Nervous Activity. In this paper, they introduced the architecture that mimicking human brain, something like this, the very simple neuron. So this is the neuron, the body, this is the input, and then this is the output, the axon. This is dendrite, axon, this is the body. So weight here and threshold, yeah, this is the threshold. This is um, like the synapses, yeah, in our brain. So they want to fire the output, yeah, they want to activate the output based on this threshold. Yeah, the threshold is 0 in here. So the way they doing this is they make something like this. They make the line like this: x plus y minus 1.5. Okay, so this is the weight, this is the weight, this is the weight. Okay, so in graphical visualizations, we can see something like this. For the logical operations such as AND, so this is AND, 0 and 0, the output will be 0. 0 and 1, the output will be 0. 1, 0, the output will be 0. 1 and 1, the output will be 1. Okay, so if we see the output, this is y equals to 0, 0, 0. The data will lies below this line. And then for the positive data, yeah, y equals to 1. Okay, so the data lies above the line. So this line, the linear equation for this line is x1 plus x2 minus 1.5 equals to 0. So the 0 here is the threshold. Whenever it above the threshold, it's positive. Whenever it's below the threshold, it's always negative. Oh, sorry. Negative here means 0. Okay, so if we see the architectures, this is the same, yeah, dendrites here, and we have input here, we have cell body here, we have nucleus, so this is the body, the neuron, and then we have the output, this is the axon. Okay, I'm going to explain a little bit using very simple example. Okay, each day you get lunch at the cafeteria. Your diet consists of fish, chips, and beer. You get several portions of each. The cashier only tells you the total price of the meal. After several days, you should be able to figure out the price of each portion. Each meal gives a linear constraint on the price of the portion. So, in our brain, we already know how the cashier calculate the price. So it is like this. The portion of the fish that we ate multiplied by the price, okay, and then plus the number of portion of chips that we eat multiplied by the price of the chips plus the number of beer that we drink multiplied by the price of the beer. It's very simple equation. And then how do we know the correct price? Assuming that we don't know the price, we only know the total of the meal cost, yeah, for a week. Okay, so we can do that by guessing the weight and then adjust the guess to give a better fit to the price given by the cashier. Okay, so for example, the price of the meal is 850. We know this already, yeah. And then we also know that we eat 2 portions of fish, 5 portions of chips, and 3 portions of beer. We never know the price. So this is in the cashier brain. Okay, one way that we can do is we guess with initial guessing. For example, we guess, okay, I'm start with 50 each. 50, 50, 50. When I put the calculation 50 times 2, 50 times 5, 50 times 3, I'm adding up everything and I will get the price, the total price is only 500. That's mean it has error as big as 350 because the correct price meal is 850. So I have like 350 residual error. So this is bad, right? I want to improve this number to closer to 850. Okay, so I'm going to update the weight. This is the weight. I'm going to update the weight. How to update this? We're using this formula. Delta of weight is we're using this learning rate, and then this is the input, and then this is the difference between the correct output minus the predicted output. Okay, so when I'm calculating using this formula, I will come up with a new weight, which is 70, 180. Okay, so if we go back to here, okay, so my first guesses is 50 each. My new guesses after so this is 500. My new guesses after I updating my weight become, this is 70, this is 100, and then this is 80. If we see, this is the correct weight. So if you see something like this, okay, the first guess is okay, is improved. The third guess is also improved. How about the portion of chips? This is already close, but since we updating using the formula, then it become very far. So this is worse. And then we come up with something weird, yeah. And then we ask ourselves, do the updates to the weight always make them closer to their correct values? No, the answer is no. Example is the chips value. How quickly the weight converge to their correct values? It can be very slow if two input dimensions are highly correlated. For example, ketchup and chips. Can the iterative procedure be generalized to much more complicated multi-layer nonlinear nets? The answer is yes. So we keep repeating the learning, we keep updating the learning in such a way that we can guess this correctly, yeah? And then we can come up with 850, nearly 850. We need to do the iterative process. Okay, so you can try this to understand how the perceptron work. And this is the discussion topics for group 1. Conduct a mini research on, make a comparison table between biological neuron versus artificial neural network, and then you need to explain this. What is a single layer neural network or perceptron? Please explain how does they work, and then what happen if you apply perceptron for logical XOR. Yeah, in example, I already give you how to solve the logical AND using perceptron, and now you try using the perceptron for logical XOR. And then how perceptron learns. How does a perceptron find correct weight parameters to build a good classification models? Okay, thank you. We're going to continue to parts 2.